Hi there, Year 9. It's good to have you with us. This is the entire Year 9 curriculum that we're going to go through in this course, not in this one video, because that might melt your brains, but we're going to go through slowly in this course all the modules, all the units, all the parts of the Year 9 curriculum, which will have you in good stead for Years 10 and 11. And those all crucial GCSEs or functional skills at the end of them. So we're going to start with a module on number, getting ourselves in a good starting place. Now, quite a few of these topics I imagine that you have seen before, but we're going to go over them just to really bring them back out of the long-term memory and bringing them to the forefront. So this video, we're going to look at accuracy and estimation, things like rounding. We're then in the next video going to look at the rules of indices, standard form, and then the final video in this unit, prime factors, HCFs and LCMs. So let's dive straight in. Why do we round numbers? Well, we round numbers to make them simpler. It makes them easier to use in our heads to calculate, or if we have a really, really long decimal that goes on and on and on and on and on, that's going to be really clunky to handle. We only need it to a small degree of accuracy to be able to be practically able to use it. So we round them to make them simpler. Okay, we've got a lot of different methods that we use to round them. You might see questions saying to round to the nearest whole number. We might be asked to round to the nearest 10 or 100 or 1,000. You get the idea. We might be asked to round to a decimal place. You might be asked to round to 1 decimal place. Now, you might see this shortened to 1DP, rather than having to write decimal place out all the time. That's what that means if you see it, but that's what we're talking about. 1 decimal place. We might be asked to do 2 decimal places. That's particularly key when we're dealing with questions involving money, because when you're dealing with pounds and pennies, the penny parts of the pounds is 2 decimal places, or sometimes 3 decimal places. We don't usually see much beyond that, but you might be asked for it, and the principle is still the same. You might also be asked to round to significant figures. Now, we're going to talk about what significant figures are later in this video, but you might be asked to round to 1 significant figures, SF, that's what that stands for. As you can see, we can be a little bit lazy about how many words we write. So 1 SF is 1 significant figure, 2 would be 2 significant figures, and sometimes 3. Let's just make them look like more like Fs than Ts. So there we go. That's the different methods, the different ways that we might be asked to round. So looking at these questions then, let's do a couple of examples to picture how it works before we can then do some more questions. Now, what you might have been told or learned before is that when we're talking about rounding, 5 or above, we round up, and 4 or below, we round down. But let's picture how that's actually working. 18.6 to the nearest whole number. So that is between 18 as a whole number and 19 as a whole number. And in the middle, slap bang between the two, we have 18.5, halfway. Now, anything that's this side is going to round down to 18. Anything that's this side, and including the 18.5, rounds up to the 19. So now let's look where our number is. Our number is 18.6. That's going to be about here-ish. So it's bigger than 18.5. We are rounding up to give us an answer of 19. We've got the same principle with the next one. Between 34 and the next whole number above would be 35. We're between these two values. And then in the middle, we would have 34.5. So this side would round down. This side would round up. And where we are is about here, 34.2. I'm not doing this accurately, it's just enough for me to picture what's going on. So I'm on the left-hand side of the 34.5. I'm smaller than 34.5. I am going to round down to 34. And hopefully we can see this is a 6, 18.6. It's 5 or above, we're rounding up. This is 34.2, we're rounding down. 2 is smaller. We could do it to the nearest 10. So the nearest tens, 417 is between 410 and 420. Those are the nearest tens. And halfway between is going to be 415. So if I put my arrow in, let's go for blue like I've done. 417 is going to be over here, probably a little bit further up actually than where I've drawn the arrow, but it means we will round up to 420. And we can use the same picturing for decimals. 0.23 to 1 decimal place, that's between 0.2 and 0.3. And halfway through here, it's going to be 0.25. So my number, 0.23, is going to be about here. And it shows me that I'm going to round down to get 0.2. Hopefully that gives you a picture of what's going on, so you can practically think about what's happening. Now, this is probably a topic that you have done before, so we're not going to practice too much with me. I'm going to pause here, let you pause the video, and get you to crack on with rounding these. We're actually going to do the same numbers to different decimal places, so you can see where we round has a difference. So there are 8 questions here. Pause the video and round them all to 1 decimal place. Brilliant. Welcome back. Let's go through these and just make sure that I've got the right answer. So when I'm looking for 1 decimal place, okay, that's going to be here. So I look at the next number, and am I closer to 3.6 or am I closer to 3.7? This one here is going to be 3.7, because 3.65 would be between the two. Similarly then on the next one, here's my 1 decimal place. Am I rounding up or down? Well, let's look, I've got 9. That's definitely going to round me up. It's closer to 105.9 than it is to 105.8. Let's go for this one. Here is 1 decimal place, so be careful. But looking at this side, am I closer to 0.0 or 0.1? I'm closer to 0.1. Next one then, 1 decimal place is going to be here. So this is 35.1, because I'm closest to that. Now, when we have got lots and lots of 9s, we need to be really, really careful. Because if I put the divide in here, my 9 means I'm going to round up. But if I round the 9 up, I end up going to the next whole. So I would write this as 99.0. I still have to write in 1 decimal place. It's just that it's 0.0 in this case, because we have gone up. If you think about it this way, let's draw this one out. Okay, let's draw the line. We've got between 98.9 and the next decimal up is 98.0, or just 98. But because we're dealing with 1 decimal place, we're going to write it with 1 decimal place. In between here, 98.95 is going to be in the middle. And then our number is almost all the way up here, 98.99204. Doesn't matter about all the rest of the decimal places that are in there. We can see that we are almost at 98.0. So when we round, we're going to round up to 98.0. Let's look at the next one. So we've got 0.7293. That's going to be in here. And it's just going to stay as 0.7. Oh, I didn't put the point in. We've got this one in here. So you can see where I'm putting the line is showing me where I've got to look at the rounding. Is 0.2. And then on the final one, looking at one decimal place, it's going to be in here. This is just going to be 704.3. So just check you've got your answers there, particularly check for number 5. That was the tricky one in the middle, just to make sure that you've got those 9s rounding correctly. It's a very easy place to slip up if you're not careful. Okay, so that was practicing to one decimal place. Let's practice to 2. Same numbers, as you might notice, exactly the same. Let's see what happens when we round to 2. Pause the video and see how you get on. Welcome back. Let's crack on and see how we've got on with these. So now I'm rounding to 2 decimal places. I'm looking here. This is my gap. So this is 3.67. The 2 means we're rounding down, not rounding up. On this one, we've got the line here. So this is 105.89. On this one, it's here. So we get 0.08. We haven't done green yet. In there, so 35.06. In here, in this case, we're going to get 98.99. Because we're rounding the 2 goes down, so it just stays as it is. On this one here, we're going to get 0.73 because the 9 makes it round up. Oh, wrong way. And on the blue, so same in here, this doesn't round up, 0.17, and nor does the last one here. Oh, no, it does. See, you've got to look carefully. You put the line in, so 704.34 because the 8 rounds us up. Just check those, make sure you've got them correct, and then we'll move on to the next step. Brilliant. We are on significant figures now. So that's looking at decimal places. You can do the same principle for 3 decimal places, 4 decimal places. You've just got to put that line in to see how many places have I got left, and then look to the one to the right of it. Rounding significant figures, this often can add up with a little bit of confusion. So first things first, let's define what a significant figure is. A significant figure is the digits that contribute to an accuracy of a number. And we start counting them from the first non-zero digit. Now, that is the formal language. What it basically means is any number that's not 0 that is in the number, but anything before is called a leading 0, and anything after the number don't count. Any zeros within the number do. Okay, we do need to put the zeros in though to make sure that we keep the accuracy of the numbers, but we round in exactly the same way. So if we have a look at these numbers here, I've got 65,802, 65,082, not 802, 82. So this is my first significant figure. 5 is my second, and in this example, 0 is my third significant figure. Okay. Whereas if I look at the next one along, I've got 0.00. These are all leading zeros. They get us to the right degree of accuracy, but they are not significant figures. This 5 here is my first significant figure. So then 3 is the second. This 0 does count because it's inside the number. So that's really important to watch out for and a very easy place to make mistakes. Okay, so let's have a look at actually rounding them. The process works in the same way. These numbers might look a little bit familiar because they're the same numbers we've just done with decimal places. But because there are numbers in front of the decimal place, those are being counted in our significant figures, whereas when we just do decimal places, the numbers in front don't make a difference. So we're rounding here to 1 significant figure. So in this first one here, it's here. So I look at the 6, that means I'm going to round up to 4. If you're happy with this, pause the video. There are 7 more in this section to do. Give it a go and see how you get on. I will keep going through them in a minute to demonstrate. Okay, brilliant. Let's keep going then on these. So 105.89203 to one significant figure. Well, 1 is the first one here. Am I closer to 100 or 200? Am I going to round up or down? Well, it's a 0, so I round down. So to one significant figure, this is 100. If I look at the next one, the 8 is my first significant figure, and it's a 2 afterwards, so it's going to be 0.8. So the rounding works exactly the same way, still the same idea. If it's 5 or bigger, we go up. If it's 4 or less, we go under. But where we actually do that measurement is going to vary depending on the number, where with decimal places, it will be the same place. Last one then for number 4 in this color. So this is 35. So this is going to round up, and we're going to end up with 40 because it's closer to 40 than it is to 30. One significant figure. Same idea with this one. If we look at this, now let's be really, really careful with this one. This one to one significant figure would be 90, except for I'm closer to 100, so it rounds up. These zeros here are not significant figures. They hold the accuracy. Because if you didn't put them in, you'd have 1. And that's not the answer. The answer is 100. So zeros after the significant figures and zeros before the significant figures don't count. Zeros in the significant figures do. Okay, let's keep going. We've got 0.7293. So this is going to be my first significant figure, is the 7. So this is going to be 0.7 in this example. I've lost my pattern of colours. Next one here, again, one significant figure. The 1 is the first digit. So I'm going to end up with 0.2 because the 7 means it rounds up. And then finally on this last one, 704. Again, here is where we're looking for the significant figures. This is just going to be 700. So that's the one significant figure. Now, these are really good. We're going to do some questions on them later, but we round to one significant figure to get estimates because numbers with one significant figure are seriously easy to handle compared to 2 or 3. But if we're dealing with sciencey contexts or just more detailed questions, we might be asked to do 3 significant figures. This is quite a common one to have to practice. So same numbers again. Let's see what the difference is, though, when we round them to 3 significant figures. So here we go. Let's start counting them in a different color. So this is the first, the second, the third. In goes my line. So now I'm going to round the 2, means it stays down. So this is, oh, that didn't write very well, 3.67. If you feel like you can do this okay, pause the video, crack on with the rest of them. If you're not so comfortable, we'll go through them all in a minute and let you see how I'm going to do it. Okay, welcome back. So we are going to crack on. So you're either going to check your answers or work through these with me if you're not sure. So 1, 2, 3 significant figures. This 0 here counts as a significant figure because it's inside the number. So I'm drawing my line in here. The 8 means I'm going to round up. So I get 106. Okay. As previously, these 8s, these zeros before the 8, 0 and 0, don't count as significant figures. So 1, 2, 3. So let's change the pen so you can see the different colours. This is 3 significant figures, and it's a 0 afterwards. So this is just 0.0821. We need to keep these in to get the degree of accuracy. These are then significant figures. Then this one, 35.0. So this is 1, 2, 3. Put the line in. This is going to round up. So I'm going to get 35.1. But the decimal places are still staying in the same place, still the same number, same degree of accuracy, just where we're cutting them off. Red, again, can you see I like doing it in patterns? 3 significant figures. 1, 2, 3, that goes in here. Now, again, we've got to be careful on this one because this is going to round this one up and this will round this one up. So to 3 significant figures, this is 99 0.0. This 0 does matter. It's a third significant figure. It tells you that before you rounded it, there were other digits involved that have then led to the rounding of this. So that's just important to recognize. If it says 3 sig figs or decimal places and you have got a 0, write it in. Let's have a look. So 3 significant figures, 1, 2, 3 goes in here. The 3 is not going to do anything. So this is 0.729. We've got 1, 2, 3 going in there. This 9 is going to affect it. So we're going to get 0.173. And then finally, on the last one here, as we said before, this 0 counts. So 704, 1, 2, 3. In here goes the sort of dividing line, the line to show us where we're going to round. The 3 to the right of it says we're going to move, round down, not move down, we're going to round it down. There's nothing afterwards that would indicate that we're going to round up. 3 is smaller than 5. So that's rounding to 3 significant figures. So hopefully you're feeling more comfortable now. A lot of people get confused between the two. Generally, decimal places are for when we've got zeros in front or when we're dealing with money, but you can round. Significant figures are when you're going to be dealing with bigger numbers in front of decimals. But that's generally, you could be asked to do either with either number, with either type of number. But the rounding technique still stays the same. Now, we've got a new bit that's just slipped in. It's a very, very tiny bit. So we're just going to look at it now. It's called truncating a number. Now, truncating is different from rounding. It just means literally chopping the number off. Okay? We need to put in enough zeros to make sure it's the same value. So we need to keep the accuracy, but we are just going to chop without rounding. So if I wanted to, I can't do this one to decimal places, but if I wanted to truncate this first one to the thousands, I would look at this, okay, and I would just write 65 and then zeros afterwards to make sure that I've keeping its accuracy. Okay, whereas on this one, to a given number of decimal places, if I said truncate to, let's go 4 decimal places because of where we've got the zeros, 1, 2, 3, 4, 0.00353. It doesn't matter if we were to have anything here that could round, we wouldn't. We would just get rid of it. So it's very, very small. That's all the time, apart from some questions I want to spend on it. But it's just worth noting the difference between rounding and truncating. So just to have a quick practice, we're going to go to 2 decimal places with all of them, and we're just going to truncate them. So pause the video here, see how you get on quickly, and restart me when you are ready. Brilliant. Okay, let's crack on then. I might just do these all in the same color to keep this going. 3.67. It's not going to be rounded. Doesn't need to be rounded. 105.89, not rounded. 0.08, again, not having to worry about rounding on that one because it's rounding down. 35.06. This would be 98.99. Now, 6 is when we're going to see the difference. All of these have just been chopped. We would have rounded down to 2 decimal places. That's fine. Whereas on 6, this is going to be 0.72. If I was rounding, it would become 0.73, but I'm just truncating, I'm chopping it, and we're getting rid of it. Looking at the next one, this is just 0.17, and this is 704.33. Again, not rounding, just chopping off the number and losing it. So that's all the time I want to spend on truncating. It's not a big topic, it's a really, really tiny one, but we have talked about it briefly. So we've talked about how we can use this then. We use this in estimations. If you had to do that calculation without your calculator, that's going to be a real pain in the neck to do. I mean, I wouldn't be able to do that without my calculator or a pen and paper. What I can do, though, is I can round my numbers to one significant figure and calculate with those. It'll give me an estimate, a rough idea of what the answer is. So if I demonstrate it with this example here, and then we will see how we can apply it. So I will do the first one and then I will let you do the second one. So 24.38 times by 3.1, all divided by 3.89 times by 2. Well, if I was to write this out rounded, this is pretty close to 20. To one significant figure, we'd make that 20. It's closer to 20 than it is to 30. I'm going to times it by 3, one significant figure. And then I'm going to divide that by, that's pretty much 4, 3.89, times by 2. Now, if I was to do this, this is 3 times 20, this is 60, divided by 8. Now, might not be able to do that in my head, but I can certainly cancel it down. That's 30 over 4, which is 15 over 2, using my skills with fractions, which is 7.5, if you wanted it as a decimal answer. Still not great, but you can see how it's much, much easier that we should have an answer that's around 7.5 if we actually calculated it. So pause the video here, have a go at the one on the other side. Brilliant, welcome back. Let's have a go at this and let's see what we can do. So 30.11, let's make that 30, plus 19.3, let's make that 20. And that's all divided by 1 times by 5. Well, this is then 50 on the top divided by 5, which gives me an answer of 10. Now, what you could do to have a look is to put those two numbers into the calculator and see what you actually get. See if your answers are close to 7.5 and to 10. It gives us a working value that we can use. We can also do estimates to work out a calculation is right. So if we have a yucky calculation to do, and particularly something that is on a non-calculator test or paper, or we don't have a calculator to hand, we can do the estimates to check that the answer is right. So compare them. If your answer is close to the estimate, or your estimate is close to the answer that's given, or the answer that you worked out using the calculator, make sure you haven't had a typo or a whoopsie moment, you can check. If we have a look at this example then, so we have got, Charlie has worked out that 5.2 times 3.9 times 2. He uses a calculator and gets 425.88 as his answer. Saida works out an approximate answer for the question. She knows from this that Charlie's answer must be wrong. Write down the approximate values for 5.2, 3.9 and 2.1 and use them to find a rough example. What mistake has he made? So here we go. 5.2 is pretty close to 5. 3.9 is pretty close to 4. And 2.1 is pretty close to 2. We've rounded them there to one significant figure. So we can use those approximations to work out a rough answer. So 5 times 4 times 2. Now, hopefully we can do that in our heads. This is 5 times 4 is 20, times 2 is 40. So a rough answer gives us 40. Charlie gets 425.88. So he's out by a power of 10. He's probably done the calculation right, but what's the mistake? He's either misread the decimal, or he's dropped one when he was doing his calculation. Because hopefully we can see that if we know that the rough answer is 40, then the accurate answer is 42.588. He's just put the decimal place in the wrong place. For either one of the points in the question, he's either done 52, or he's done 39, or he's done 2.1. and mistyped to get the answer, or misread the question, misread the answer, and put the decimal place in the wrong place. So we can adjust our answer looking at a degree of accuracy. This can be really helpful for non-calculated calculations. So let's have a go at some of these ourselves. Now, they quite like putting these in the context of wordy questions. So we will let you have a go. Pause the video, have a go at these two, and we'll see how we get on. Okay, welcome back. Let's use approximations then to find out whether Eddie or Ellen is correct. So what we're going to do, we're going to look at this 431.1. Let's make that 400 to one significant figure. We're going to divide it by 14 plus 4 squared. Now, don't those numbers look easier? This then becomes 400 over 14 plus 16, which is then 400 divided by 30, which if you cancel them down is 40 over 3. Now, if we were to do that in our heads, 39 divided by 3 is 13. So we know our answer is roughly about the 13 mark. So Eddie has an answer of 1.5 and Ellen has an answer of 15. Ellen is going to be the one that's correct because she is closer to that 13 that we've estimated. The 1.5 is out by a multiple of 10. So that's something you can watch out for. Okay, and use approximations. Similarly, for the next one, use the calculation. Sorry, let's read that again. The calculation 41.5 times 66.3 is equal to this number, but it's missing a decimal place from the answer. Use rounding and estimations to work out what it should be. So this is roughly 40 times roughly 70, which if you were to calculate in your head is 280. 4 times 7 is 28, and then the 2 zeros, 280, which means if I'm calculating this one, the decimal place is going to be around here. We get 275.145 because our estimate is close to our actual answer. Okay, we've got some here then for you to have a practice at. Have a look at these and see if you can work out who has got the right answer to each question. Pause the video and see how you get on. Okay, welcome back. So I'm going to write the estimated, the rounded calculations on the side so you can see. So this is roughly 1 times 3. So my answer is going to be the one that's closest to 3. So in the first part A, Ali is right. Looking at the next one, this is roughly 1 times 50. So the answer that's closest to 50 is going to be this one here. So Nigel is correct for the second one. 4.8 times 10.4. So this is roughly 5 times 10. Again, we're around the 50 mark, which is going to be this one here. Back to Ali. We have got then the next one. We can do these calculations for divisions as well, and additions and subtractions. It still works. So this is roughly 30. Let's say that's 30 divided by 10. So the answer that's sort of in the region of 3, which means Sue has got that answer correct. Hopefully you can see how I'm using my estimates to get an idea, and the closest value in the table is then correct. So this is now 40 divided by 8, which is roughly about 5. So I'm going to say that that's this one here for Nigel. We have then got 7 times 7. We'll just, 7 times 7. 7.1 rounded both times gives me 49. So that's pretty close to 50. So it's going to be that one. So Nigel again. We have got 27 divided by 5. That's not so nice to work out. Oh, no, 27 is not going to be so good. Let's go with 30. That's one significant figure. 30 divided by 5 gives me 6. That's easier to work out. So the answer that's kind of close to 6 is this one here, 5.8. We have got 76 divided by 47. Now, you might already be doing some of these calculations in your head to make sure that you've got them right. 76 is about 80, 47 is around 50. This is about the 1.6 mark, and that is a decimal that I know because it relates to the conversion between miles and kilometers. But you could put that in a calculator and work it out if you needed to, or do it using your knowledge of fractions. So 1.6 for that one. Just to give you an idea, we're going to go back to green. So we've got 12 times, so 13 times by 9. Or no, 13, that's not good. That's 2 significant figures. Let's make it 1 significant figure. So 10 times by 9 is 90. So that's the 107 is the closest one there. So Ali's got that one right. And then finally, 8.342 divided by what is effectively 1. So this is 8 divided by 1 is effectively 8. Hopefully that wasn't too bad. So we know that Sue has got the last one right. So hopefully you have got all the correct answers there and you can see how I've rounded. Be careful because sometimes your gut instinct is to round to the nearest whole, but the calculations will be easier to the nearest significant figure. As you can see, I did that twice. I went for the nearest whole, but actually the calculation was easier to do to the nearest significant figure. Okay. So now I live in an area of the UK that's got a lot of fields. We are a very country part of the world. So working out how many cows you can get in your field is actually, strangely enough, a real part of life in my part of the world. Probably not if you're in a more urban area, but we can still use the maths. A farmer has a field. Calculate the area for the field, and then each cow needs at least 4.5 meters squared of room in a field. Use your answer to part A to estimate the number of cows that can be placed in the field, the maximum. Now, keywords here are estimates. We are rounding. So have a go, pause the video and see how you get on. Okay, welcome back. Let's have a go. So 19.51 is pretty much 20 and 9.92 is pretty much 10. So to calculate the area of a field, hopefully you remember this is a rectangle in the picture. Area of a rectangle is its length times its width. So we've got 20 times by 10, which is going to give us 20. Now let's check our units because it's an area question. It's always a good idea to check our units. Meters times meters, we are meters squared. Now each cow needs at least 4.5 meters squared of a room in a field. Use your answer to part A to estimate the maximum number of cows which can be placed in the field. So we're going to use this answer here. So I've got 200 meters squared to be shared out, and each cow needs, well, if I'm going to round this, 4.5 is going to round to 5 to calculate with. So I do 200 meters squared divided by 5, which gives me 40 cows. Hopefully you got the right answer there. Do just check your units when you are dealing with real life situation, particularly area, volume, money. Things can easily slip and be missed. Okay, here's another money one because we can work out calculations with money. In fact, you might find that you do calculations in a shop if you're out about shopping with estimates rather than with the actual figures to give you a rough idea. Okay, so Dennis gets paid £7.49 per hour as he works in a workhouse. Dennis works 41 hours a week. Work out an estimate for the amount Dennis gets paid in a week. So have a go at this one. See how you get on. Okay, let's have a look at this one then. We are going to round 7.49. Well, that's going to go down to £7. And we're also going to round the 40 hours down to 40 hours. The 41 has rounded down to 40 hours. Okay. And the reason I've made a note of whether we're rounding down or rounding up is for part B. So how much is he going to get paid a week? Roughly, he's going to get paid 7 lots of 40 hours, or 40 hours at £7 each. That gives me £280 in a week. Now, is it an overestimate or an underestimate? If I have rounded both numbers down in this situation and it's a multiplication, I'm going to have an underestimate because actually he gets paid a bit more and he works a few more hours. So this is an underestimate. So always worth having a look at the context of the question and have a think to see whether we're over, under, or if there's not enough information to tell us. Let's have a look then at the next one. Rounding errors. So we've done all the work on rounding, but it can be really useful to have a look at the error that we have left when we round. So let's show you an example, because what we have left when we've done a calculation, it's an approximate answer, it's an estimate, it's not exact. The rounding error is that gap between the rounded and the exact. Doesn't matter which way around you do the calculation, we just want the difference. So what's the rounding error when 46 is rounded to the nearest whole? Well, 46 is the nearest whole. So 46.3. So then my error is 46.3, take away the 46, which just leaves me with an error of 0.3. Now, again, this is a really small topic, so we're just going to go through these questions quite quickly to finish us off before we look at error intervals. And then we're done with this unit and you can go and move on to indices or something more fun. So find the rounding errors for these. So always a good idea to write out what the rounded value is. So the rounded value for this is going to be 30. So then my error is 34 minus the 30. I've got a rounding error of 4. If I do 112.7 to the nearest whole, well, the nearest whole for that one is 13. So I'm going to do 13 minus the 12.7 to get 0.3 as my error. If I've got 8.65 to one decimal place, well, rounded, this is going to give me 8.7. So then the difference I've got here, 8.7 minus 8.65. I'm just looking for the difference. It doesn't matter which way around I'm doing it. 0.05 is what's different. And then finally then, if I round this one to 2 decimal places, I get 67.73. So then 67.734 minus 67.73 is going to give me a rounding error of 0.004. So that's the rounding errors when we look at the difference between our exact value and our rounded value. But sometimes it's a bit more broad than that. Sometimes we might not have what the answer is. We might just be told that something has been rounded to the nearest 10, to 1 decimal place, to whatever it is. So when we're looking at these, we can look at what's called the error interval. What's the maximum value that would round down and what's the minimum value that would round up? Now, the maximum rounding error is going to be half of the rounding unit. So if we're rounding to the nearest 10, then we're going to 5 on either side of our number. Think about that with the diagram. If I'm rounding 34 to the nearest 10, I looked at 30 and 40, and 35 is going to be my upper limit. And similarly on the other side, 25 is going to be the lowest limit. Anything smaller than 25 would round down to 20. If it's to the nearest whole, then it's 0.5 on either side. And if it's 1 decimal place, 0.1, then the maximum error is going to be 0.05. The actual value could be anywhere between half a value bigger and half a value smaller than our rounded answer. Now, we use inequalities. There is a whole module on inequalities and how we use them in algebra coming up. I think it's unit 3 off the top of my head. But we can still use them. So our inequalities are our greater than and our less than symbols. So we've got them that go this way. And if we include the number, we have the equals sign underneath. So let's have a look at this. a length x is measured as 3.7 to 1 decimal place. What's the maximum possible rounding error? So if it's 3.7, the biggest number it could be before it turns into 3.8 is going to be 3.75. Now, the reason I write that is because 3.7499999999999999 and so on still rounds down. So what I use is my inequality that tells me that x has got to be smaller than 3.75, but doesn't include 3.75. That would round up. And on the other end, what's the biggest value that would round up? The smallest value that would round up to 3.7 is going to be 3.65. Now that one does round up, so I use the inequality with the equal sign. So these are the inequalities that you're going to get every time when you're doing rounding errors. It's always going to be this way round. And we've shown the range. So x could be any value between 3.65 and 3.75, and they would round to 3.7. So very last bit of today then is to find the range of possible values between these ones. Pause the video if you are happy to charge on. If not, I'll be working through these in a minute. Okay, let's have a go at these then now. Now we're back from the pause and see how we get on. So 87 to the nearest gram. So the smallest value this could be is 86.5 grams, because anything smaller than that is going to round down to 86. But we do include it. We're going to round it up if it's 86.5. And at the other end, everything up to but not including 87.5 is going to round down to 87. So our error interval is all the values of x between 86.5 and up to but not including 87.5. Okay, having a look at the next bit then, we have got 500 to the nearest 10. So at the lower end, we've got 495, because anything smaller would round down to 490, and up to 505, but not including it. Similarly, on the next one, I've got 37.35. Anything bigger than or including that would round up to 37.4. And less than, we have got 37.45, because if we had 0.45, we'd round up. 2 more to go. 2 decimal places now, so we can keep doing this to lots of degrees of accuracy. This is going to be 45.855 would round up to 45.86, and 45.865, but not including that one, because that will round down. 30.9 to 1 decimal place. Let's be really careful with this one then. So smaller than, we could have 30.85 would round up to 30.9 to 1 decimal place. And on the other end, we would have 30.95. And you've got the inequality symbol here showing that we don't include that 0.95. That would round up to give us actually 31.0 when we got there. So those are our error intervals. So that's a really good topic to get your head around if you can possibly manage it. So that's it. That's our rounding and our estimations. There's quite a lot of little bits of practice in the red book. So exercise 1 on page 6, exercise 2 on page 7, exercise 3 on page 9, exercise 4 on page 11, the mixed exercise on page 12, and if that wasn't enough, there's also pages 7 to 9 in the targeted workbook. So there is plenty there to be getting on with. Just do as much of that as you can to make sure that you are comfortable with the topic. But in your hands to practice. I look forward then to seeing you for rules of indices in the next video. Have a great day.